Hey, wonderful students, it's me again, Mr. Weissert. This is going to be covering Chapter 3 for your midterm review. This is still going to be this is actually a new unit, Unit 2. This is only Chapter 3 in the unit. Here's some information for you. You can write this down. There's actually another page of it, so I'll leave that here for a second. If you had me, you likely used flashcards to help you do some interpretations. You won't have that opportunity on exams, of course, but you can go back and study them if you need to help you remember some of the interpretations. This one was pretty heavy on the writing. Here's some more, talking about scatter plots and how to interpret and read from a computer output. I'll let you read through that and make any notes that you need. All right, let's begin. This is a long question, so it's going to be multiple pages. The first part of it is talking about R and talking about the relationship you see. So let's look at the question. A random sample of AP statistics teachers was asked to report the age and years and mileage of their primary vehicles. Well, let's see. My vehicle is 4 years old and has about 70,000 miles. That looks like it falls within the range of acceptable values. So looking at this data here, you got to make sure you know how to get the slope and the y-intercept. So I'm going to actually write that down, even though the question's not asking for it. When you see the word constant, that's going to be your intercept. So that's kind of like your A. We always start with your A. That's going to be your y-int. And then the number over here is going to be your slope. We call that the B. And this R squared is your coefficient of determination. S is the standard deviation of the residuals. When you write your function, it's going to look like y hat. That's the predicted y equals a plus bx. So if you substitute a and b in there, you can get the equation. But I often find it's just easier to write the instead of y, I would write the predicted. In this case here, we're talking about how we're predicting mileage. So mileage, and that's going to equal a. So 3704 plus b 12188. And then my x value is going to be age of the car. So I'm actually just going to write age. Now it's important you put that little hat over there. That means predicted, not the actual mileage. The actual mileage are the points over here. So you're going to have to know how to write that equation. So jot that down anyway. Now, the value of the correlation coefficient R, well, you'll notice that they're going to give you R squared in these. They never give you R, at least in these computer outputs. Well, I shouldn't say never, but they usually don't give you R. So to get the R, you take the square root of that. You got to be careful though, because I know R squared is 83.7%. You want to make sure it's a decimal. And when you square root that, you're going to get 0.9149. And that generally translates to being a strong relationship. But you have to look at the relationship itself. Look at the data. If it's going down, that's going to be a negative. So you get lucky if you forgot to do that, because this is a positive slope. So since the slope's positive, R will also be positive. You don't need to write that phrase on here, but you have to know that you got to change it to negative if the slope's going down. Letter B, based on the scatter plot and summary statistics, describe the relationship between mileage and age in years of AP statistics teachers in context. So on these problems here, we want to talk about something called DUFs, direction, unusual points, form, and strength, always in context of the problem. So direction being, is it going positive or negative? Unusual points, are there any outliers? Form, linear or nonlinear. Strength, strong, strong, weak, moderately weak, that kind of stuff. So I would see if you can write down a phrase that represents this information. If there are no outliers, don't mention them. All right, I'm going to reveal mine. So if you haven't written yours down, you might want to pause before I reveal them. Here we go. I said, and I didn't have a lot to say here, there is a strong positive linear relationship between age of car and years and mileage. That covers all of these, and it doesn't cover unusual points because I do not see any points that would be considered outliers in this case. So I left that alone. Let's go to the next question, or the same question, the next couple parts. Back to the same data, you're going to be asked to interpret a couple things. So in this case, it says identify and interpret the slope of the least squares regression line. Well, remember the slope is right there. So identifying it's the first thing, but that ain't going to get you much unless you do something with it. So there is a template. The way that slopes work is as the x value increases by 1 unit, the predicted y value increases by or decreases if it's negative, whatever the slope is. Here's my template that I use. For each 1 unit increase in x, the predicted y in the context of the problem increases or decreases by the value of the slope in units. So I will write something like this. The slope is 12188, and that's in miles. This means that for each year increase in age of the car, the predicted mileage increases by about 12,188 miles. Letter B, interpret the coefficient of determination. Sometimes they don't even let you know coefficient of determination is r squared. So you have to know that that's r squared. You got to identify that. Just writing the number isn't going to do much in this problem. But there is a default template, and people really have a hard time with this one. So here's how the template goes. I say the following. I say blank percent of the variation in whatever the y value is accounted for by whatever the x value is, and always in the context of the problem. I don't do a whole lot extra with it, and there are more complicated variations of that same thing, so I kind of stick with just x and y. The variation is always in the y, not the x. How do you write that in this case? I say 83.7% of the variation in car mileage is accounted for by the age of the car in years. Makes sense? All right, let's go to the next question. Pause the video. I went ahead and included the slope-intercept form of the equation again, just so you can kind of see what that looks like. I don't think we're going to need it here. But based on the plot, what is the approximate age and mileage of the car with the largest absolute value residual? In other words, just how far, which point is the furthest vertical distance away from the line, regardless of if it's below it or above it. And I can tell you right now, I look at one point right here, it seems to be very, very far above that. Maybe using red's not the best option here, so let's use a different color. And I don't know how many far above it is, but dang, that's pretty far. So I'm going to wager that that point right there is going to give you the largest residual. So what I said was the age of the car with the largest absolute value residual is about 2 years, and it has an approximate mileage of 90,000. Now, I don't know if it's exactly 90,000, but I know it's above 80 and below, if that's 120, that's 110, 100. I just estimated 90,000 on that. It doesn't have to be exact. All right, the last one. Does the LSRL, least squares residual line, underestimate or overestimate the mileage of the car identified in Part E? Well, if that point is above the line's going to underestimate it. If that point is below the line will overestimate it. So what do you think? That's right. Since the residual is above the line underestimates the mileage of this car. That concludes our review for scatter plots. This is Chapter 3, Unit 2. We'll get into sampling and experimental design next video. Thank you for watching.